All right, let's dive straight in. Today on the deep dive, we're tackling a really interesting area, especially I think if you're prepping for those senior software engineer
Oh,
interviews.
yeah. What do we got?
It's all about handling code reuse when you're building systems with microservices.
Ah, okay. Yeah, that's definitely a common challenge. We all know that core idea, right? Don't repeat yourself, DRY.
Exactly. Keep the code base clean. Don't duplicate behavior or knowledge. It helps prevent bugs, makes things easier to manage. Simple enough in theory.
Right, in a monolith, you just abstract things out,
Yeah.
functions, classes.
But when you slice things up into independent microservices, each with its own deployment cycle,
Uh,
well, applying DRY isn't quite so straightforward anymore.
it really isn't.
Yeah.
That's kind of the puzzle, isn't it? How do you avoid repetition when everything's supposed to be separate? Because just sharing code across those service boundaries can cause some real headaches down the line.
So that's our mission today, basically. Let's explore the common ways people try to reuse code in the microservices world. Look at the different strategies, the pros and cons.
Yeah, weigh the trade-offs. Hopefully give folks some solid points to think about for those technical chats.
Okay, so where do we start? The most obvious place seems to be sharing code using libraries.
Makes sense. DRY kind of pushes you towards reusable bits, and libraries are the natural way to package them up, right? Find common stuff, bundle it, let services pull it in.
Seems clean. You write it once, use it many times, problem solved.
Well, not always. This is where that nasty issue of tight coupling can sneak in.
Ah, okay. Explain that a bit.
Sure. So imagine you create a shared library with your core business objects, maybe customer order, that kind of thing.
Yeah, standard practice in many places.
Right. But now, let's say your ordering service needs to add a new field to the customer object. You change it in the shared library. But suddenly, your billing service, your shipping service, maybe even your marketing service, they all now depend on this new version of the library. They have to be updated and redeployed.
Even if they don't actually use that new field.
Exactly. Even if they don't care about it. And think about message queues if they're passing these objects around. You could get version mismatches, serialization errors.
Oh, yeah. If you forget to update just one service that consumes those messages, things could go sideways fast. It's like a domino effect.
Precisely. It's a classic coupling problem. Now, it's different for, say, a shared logging library, right?
How so?
Because logging is usually an internal implementation detail. The outside world, other services, they don't interact with your logging format. So sharing a logging library doesn't really create that external coupling between services.
Okay, that distinction makes sense. It's about whether the shared code affects the interface or contract between services.
Exactly. The risk is highest when the shared code defines data structures or business logic involved in that inter-service communication.
You know, it's interesting. I heard about realestate.com.au doing something counterintuitive. Apparently, they copy a whole service template for each new microservice instead of sharing one.
Really? That sounds like the opposite of DRY.
It does, but their rationale was explicitly to prevent any chance of this kind of coupling creeping in through shared templates or libraries.
Huh. That really highlights the trade-off, doesn't it? Except a bit of setup duplication to guarantee independence later on.
Yeah. So, okay, back to libraries. What about actually updating them? It's not like there's one central copy running, right?
No. Typically, each microservice packages its dependencies, including shared libraries, inside its own deployment unit.
So if you fix a bug in the library,
You have to redeploy every single service that uses it to get the fix individually.
which means you could easily have different versions of the same library running across your system at the same time.
Absolutely. Version V1 running in service A, V1.1 in service B. And maybe that's okay sometimes, if the team is comfortable managing that. But it adds complexity. What if V1.1 has a subtle change that breaks something when interacting with V1?
And trying to coordinate a big bang simultaneous deployment of, say, 10 microservices just to update one shared library? Uh, that sounds incredibly risky.
It really is. High coordination costs, high risk.
Yeah.
So yeah, libraries can work, especially for those internal things like logging, maybe some utility functions, but you have to be super careful about coupling, and you need a plan for managing updates.
And if you absolutely need a piece of functionality to be consistent and updated everywhere simultaneously,
Then maybe that piece of code shouldn't be in a library. Maybe it needs to be its own microservice that others call.
right, encapsulate it completely. Okay, that leads us nicely into another approach. Client libraries, what's the idea there?
So client libraries are about making it easier for consumers of your service to interact with it. Instead of every client writing the code to make HTTP calls, handle serialization, maybe deal with some basic error handling.
You provide them with a library that does it for them?
Exactly. Import the library, call a function like getUser, userID, and it handles the underlying API call. The argument is ease of use, less repetitive boilerplate code for clients.
Sounds helpful on the face of it. Less work for everyone using your service.
Yeah.
But you mentioned potential downsides earlier, especially if the same team builds the server and the client library.
Yeah, this is where things can get problematic. There's a real danger of logic sort of leaking from the server into the client library.
Leaking logic, how?
Well, imagine the team building the service knows certain validation rules apply. It might seem convenient to just put those validation checks directly into the client library they're also writing.
Ah, I see. So the client library starts doing work that maybe the server should be solely responsible for.
Precisely. It muddies the waters, it breaks cohesion. The client should just be responsible for making the call and understanding the response, not for enforcing the server's business rules.
And if that rule changes?
Now you have to update the server and potentially hunt down and update all the clients using that library. It defeats the purpose of having the logic centralized in the service.
Plus, what if someone wants to call your service from a different language, like Python, but you only offer a Java client library?
Good point. Mandating a specific client library can really limit the technology choices for your consumers. They might be stuck or forced to use something that doesn't fit their stack.
Okay, so that sounds like a significant risk. Are there ways to do client libraries well? You brought up the AWS SDK before.
Yes, the AWS model is often seen as a better approach. Technically, you can hit the raw AWS APIs.
But almost nobody does, right?
Right. Almost everyone uses an SDK for their language.
Yeah.
Python's Bodo 3, the Java SDK, etc. The key difference is often who builds these SDKs.
Not necessarily the same team that built the underlying service.
Often not. Sometimes it's dedicated SDK teams within AWS. Sometimes it's community efforts. There's a separation there. The SDK focuses purely on abstracting the API communication, the transport layer, the authentication, not usually embedding the service's core business logic.
That separation feels important. And crucially,
the client decides when to upgrade their SDK version. AWS releases updates, bug fixes, new features, but you, the user, pull in that new version when it makes sense for your application.
so no forced synchronized updates across all consumers. You maintain that independence.
Exactly. That client control is vital.
What about Netflix? They're famous for using client libraries extensively, aren't they?
They are. Their client libraries are quite sophisticated. They handle things way beyond just API calls, stuff like service discovery, load balancing, complex failure handling patterns, logging, monitoring hooks.
So really core operational stuff needed to run reliably at their massive scale.
Yes. These libraries are a huge part of their resilience and scalability. And they definitely boost developer productivity by handling all that complex distributed systems plumbing automatically.
But is there a but?
Well, according to some reports from people who've worked there, even with that focus on operational concerns, their heavy reliance on these sophisticated client libraries has, over time, still led to a certain amount of coupling between clients and servers.
Even if they try hard to keep business logic out.
It seems so. The lines can blur, and sometimes changes in the server still end up requiring coordinated updates or careful management on the client library side. It's a persistent challenge.
Okay, so if someone listening is thinking about providing client libraries for their microservices, what's the key advice?
I'd say first, be really disciplined about separating concerns within the client library itself. Keep the code handling the transport, like service discovery, retries, maybe circuit breakers, clearly distinct from any code related to the specific business domain or data of the service being called.
Don't mix the how to talk with the what we're talking about.
Good way to put it. Second, think really hard about whether to mandate its use. Is it essential? Or could you also just document the raw API and let consumers choose? Especially important if you expect clients from diverse tech stacks.
Makes sense. Offer it as a convenience, perhaps, but not the only way in.
Maybe. And third, always ensure the client retains control over when they update the library. Avoid anything that forces lockstep upgrades.
Client autonomy is key.
Absolutely. It preserves that independent evolution promise of microservices.
Okay, so as we sort of wrap up this deep dive, it's really clear that code reuse in microservices isn't simple. That basic DRY principle we all learn, It get complicated fast.
It really does. We've seen the trade-offs with shared libraries, potential for tight coupling, the pain of managing updates across many services.
Versus maybe using a dedicated microservice for reuse, which gives isolation but adds operational complexity.
Right. And then client libraries, they can make life easier for consumers, but carry that risk of logic leaking, tech stack limitations, and potential coupling if not managed carefully.
The main takeaway feels like there's no single silver bullet. It's all about context.
Exactly. What kind of code are you reusing? How critical is consistency versus independence? What level of coupling can your teams effectively manage?
Yeah, because while avoiding duplication is good, the whole point of microservices is often that independent deployability and evolvability. Sometimes, maybe a little duplication is the lesser evil.
It can be. Sometimes deliberately choosing not to share code or accepting some duplication is the right strategic decision to maintain that crucial service autonomy.
Which brings us to a final thought for everyone listening, especially those prepping for design discussions. Given that need for independent deployability, that independent evolution of services, how can you best mitigate the inherent risks that come with any form of code? Reuse the coupling risks in a complex system you might design or work on.
Yeah, think about specific scenarios. When would a shared library be okay? When would a client library be better? When should you absolutely insist on a dedicated service, even if it seems like overkill initially? And, crucially, why? What are the deciding factors in your context?
Lots to think about there. Thanks for joining us for this deep dive.